We're going to graph two lines that are written in different forms. This first one, go ahead and write it down if you have not done so already. It's written in slope-intercept form, which is y equals mx plus b, where your m value is your slope and your b value is your y-intercept. This form is a little bit different. Some of you may have seen it before, some of you may have not. It's called point-slope form. So you have y minus the y-coordinate of a point equals m times x minus the x-coordinate of your point. X and y represent coordinate points of a point that are on this line. So you can have different numbers representing the same line because there are multiple points on one line. Your m still represents your slope. So I'm going to show you how to graph both of these. Most of you are already familiar with the first way. We graph our y-intercept first. That's on the y-axis. So our y-intercept is a positive 4. So from the origin we go up 4, 1, 2, 3, 4. So my y-intercept, which is the point in which the line goes through the y-axis, is plotted right here. My slope is negative 3. It's easier if you put it over 1 because we would like to have a fraction. Because our 3 is negative, we're going to go down 3 spaces. And this number is negative, so this one is positive. Positive means we're going to go to the right. So I'm going to go from my y-intercept, from my last point, I'm going to go down 3 spaces and then to the right 1. Down 3 spaces to the right 1. And you need a minimum of 3 points, but as I've said before, the more points you have, the more accurate your line is. So I'm going to go ahead and draw as many as I can, just because the iPad's a little difficult to write on. And there's your line. So this line is represented through this equation. But we're going to do the same thing here, and I want you to notice something. I'm going to go ahead and use a different color for this. I want you to notice that the formula, we're subtracting the y-coordinate. We're subtracting the x-coordinate. So we're going to need two things from this. We're going to get a slope. My slope, you can easily see, is negative 3 because that's the number outside of the x parentheses. But we're going to have a point that's associated with this. The point comes from your coordinates, your x1, y1. So I'm going to go ahead and write that underneath. x1, y1, just so you can see it. And the best example is I'm just going to start with the y first. We're subtracting the y coordinate. We're subtracting 3. So my y value is positive. It's a positive 3, not a negative, because we're subtracting the y coordinate. So this, not the negative, must be my y coordinate because we are subtracting it. However, this one is opposite. We are not subtracting here, we're adding. So the only way we could subtract a number and end up adding is if this value is a negative. Because when you subtract a negative, it's the same thing as adding. So our x-coordinate value is actually going to be a negative 4. So one way you could look at it is you can look at it as being the opposite. Negative 3, oh, well, you're subtracting, so the opposite of that is going to be a positive. We're adding 4, okay, it's going to be the opposite, so it's going to make it a negative 4. So that's one way to look at the problem. So just like in this previous example, you have to start with a point. Here, our point was our y-intercept. Here, we have a different point. So before we graph slope, we must always have a point to start off with. I'm going to go ahead and graph the point from the origin. We go negative 4 up 3. This is the starting point. And my slope is negative 3. I can put that over 1. So I'm going to go down 3 to the right 1, down 3 to the right 1. And remember, as I said before, you can have a minimum of 3 points. The more you have, the better off you are. And then I'm going to go ahead and connect my points to make a line. So one thing I want you to look at is I want you to look at this graph. We just graphed two different lines, two different equations. But what I want to know is I want to know what makes them parallel. What makes them parallel? So what's going on in these two equations to make these two lines parallel? I'm going to go ahead and stop the video at this time and open for discussion.